This is problem 61 from page 120, and this is in a section where the directions are to solve each cubic equation. So we have the cubic equation x cubed minus 8 equals 0. Okay, looks simple enough. This is what we tend to want to do, but there's a problem. So here's what we would probably do. Just add 8 to both sides, cube root both sides. The cube root of 8 is 2. There we go, it's done. But if that's what you did, and then you looked up your answer in the back of the book, you'll notice they had that answer and they had 2 additional answers. Where did those 2 additional answers come from? Here's the problem. And I think it's kind of unfair of our book to not be very clear about this. This is not complete because we did not find all the solutions. We did not find both real and non-real solutions. And it should tell us to do that. But if we're looking for real and non-real solutions, a cubic equation should have 3 solutions, a quadratic equation should have 2, a linear equation should have 1. So we should really be expecting 3 solutions. So we need another way that will give us the additional 2 solutions. Now those are, chances are they're going to be non-real since what we did gave us the real solutions. Okay, let's look at this expression and let's think about the techniques we've been using for solving other equations. One of the techniques is factoring. So we have a way to factor this. Hopefully this brings to mind the formula you have for a difference of cubes, factoring a difference of cubes. Since x cubed is a perfect cube and 8 is a perfect cube, we have a difference of cubes. And remember, the formula for factoring a difference of cubes is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So if we apply that to this problem, which is x cubed minus 2 cubed equals 0, we can factor our difference of cubes into x minus 2 times x squared plus 2x plus 4. And that equals 0. And now we use the zero product property, which basically just means set each factor equal to 0 and solve each one. The first factor set equal to 0, the second factor set equal to 0. Solve the first, we get x equals 2. That's what we thought we were going to get from before. Solve the second, we'll get the other two answers. This is not factorable. So we have a choice. We can use the quadratic formula or completing the square. Either one will be fine. I'm going to use completing the square just for fun. So we have x squared plus 2x plus something makes a perfect trinomial square. I'm going to subtract the 4 from both sides. And then, of course, whatever I add to complete the square on the left, I need to add that same number to the right. So the number that completes the square is 1. We add 1 to the left, we add 1 to the right. Now we can write our perfect trinomial square in its factored form. Simplify the other side. Square root both sides of the equation. Find myself some more room over here. Actually, let's just go back and scroll. And then subtract 1 from both sides. Let's write the imaginary part of that as I square root 3. Here are the other 2 solutions. So altogether, we have our 3 solutions to our cubic equation.